let's dive into a crazy mystery. What is everything actually made of?
Okay, so what if I told you that you, me, everything, we're mostly empty space? Sounds totally nuts, right? But it's true.
And it took one scientist's brilliant detective work to figure it all out.
It all starts with the atom. This is the picture we have in our heads.
Inside, you've got three key players: protons, neutrons, and electrons.
Notice the mass. Protons and neutrons are the heavyweights. Electrons are super light.
So in 1911, our lead detective, Ernest Rutherford, had a big question.
He shot tiny positive particles at a ridiculously thin sheet of gold foil. And what happened was just wild. Almost everything went straight through.
His conclusion? The atom is basically nothing, just empty space.
The few that bounced back must have hit a tiny, dense, positive center, the nucleus.
So he pictured it like a tiny solar system, with electron planets orbiting a nucleus sun.
Great idea, right? Well, there was one tiny problem. It was impossible.
Classical physics said electrons would lose energy and spiral into the nucleus. Boom.
So if every atom should collapse, why are we all still here?
Then, in 1913, Niels Bohr showed up with a radical new idea. He basically threw out the old rulebook to explain why atoms don't collapse.
He said electrons can only exist in special fixed orbits called shells.
It's not a smooth ramp, it's a ladder. You're on one rung or another. And on those rungs, they just don't lose energy. That's the secret.
These shells, these rungs, are everything. How they fill up, basically, is chemistry. And the rules are surprisingly simple. The first shell holds 2, the second holds 8.
And this is why the periodic table looks the way it does. It's all about filling shells.
So how does this one simple set of rules build our entire complex universe?